Hi everyone. My name is Gabriel and I'm a software engineer at Inocybe.
And my name is Christophe and I'm also a software engineer at Inocybe.
Before we start the talk, please try and keep an open mind. We're just pitching ideas here, so just listen with an open mind, I guess. So the talk will be, this is going to be the layout of the talk. So we're going to talk about what is Scala, why Scala, benefit to OpenDaylight, frameworks that can be leveraged. We're going to have two examples of Scala bindings that could, in a way that we could leverage Scala with Scala bindings. And I don't think we're going to have time for a demo, but I'm going to show you a link that you can see for a OpenDaylight plugin written in Scala.
Okay. Can you hear me well now? Okay. Quick presentation of what is Scala. Is there anyone here who already developed with Scala, or are you okay? Just 1%. Okay. So Scala is really an object-oriented and functional programming language. So it can be both, actually. You can still code like you were coding in Java, but you can add it adds features to work with a function as a higher level object. It also compiles to bytecode, so it really integrates with Java and is strong typed. That means that it's not like JavaScript. Every object has a type and it's really concise. Scala actually was designed to be to reduce the verbosity of Java, and obviously it's scalable. You can do really simple programming program with it, and you also can do massive systems. Why Scala? As I said, it compiles to bytecode. It's based on JVM, so any Java programmer can really leverage his skill in Java and work with Scala. It's gaining popularity in production environments. Big players like Twitter, Netflix, and LinkedIn use it. And as I said earlier, it cut down on boilerplate code. We'll show that in later slides. Coding in Scala is really often less verbose than in Java. And for us, it's a bit subjective, but we find it, we are Scala developers, and we find it really nice and concise, and we like developing Scala. It's fun and interesting because most of the time, when you learn something new, it's fun and interesting, and it really opens up the programmer mindset because you really have to think in another way when you develop in Scala, in functional programming in general, than in sequential programming. So when you can do both, it's really interesting. I will show a little bit about the benefits we can have in OpenDaylight. So this is Scala code. As you can see, my value is not typed here, but the compiler can infer its type. It's obviously a string. And you can see the same for mylist. You don't have to specify the type of mylist. It has to be a list of strings. Then it's really concise. You don't have to add system out println. It's just println. And it's always the same in Scala. As you can see, you don't have the semicolon at the end of each line. Oh, everything is made to reduce the verbosity of the code. Then you can see that every function can be are treated as values. For example, in my function, it's you can pass a function as parameter in another function. And that's it. You can also Scala support querying. You have a little example of querying on the bottom part of the site.
Okay, so for the benefits to OpenDaylight, so as we said, we don't have to change the technology stack, so it integrates seamlessly with the JVM, cuts down the code repetition, there's less boilerplate, and one of the things that's really nifty is that it frees the developer or the programmer it frees his mind, because he doesn't have to focus on so many lines of code. He can focus on the problem that he has to solve. And he doesn't have to worry about, oh, did I forget to close this stream, or did I forget to do this and that and this? Because in Java you have to write a lot of things to do very simple things. Also, you have the ability to reuse functions, because everything is built around functions. So you kind of build a pyramid, and that pyramid is represented with functions. So you write down all your functions at the base, and then you build upon on the pyramid with all your functions. And also, that's probably just me, but I feel more productive in Scala because I don't have to worry about not forgetting to write lines, or I don't know, semicolons, or it's more concise. And also find it's easier to make mistakes in Java because since you have more lines of code, you take more chances to make mistakes. So I have a simple example. This was taken from the OVSDB project. This is the connect method, and basically we have a for loop and then a couple of if, else, if, and a try catch. So basically it just connects a bunch of nodes that have been changed, and then it invokes the connect function on those. So this is the Scala equivalent. So as we can see, first of all, there's 3 functions. By the way, I did this in 10 minutes, so it's probably a way to make it even more concise. But we can see the connect function, it passed from this to this. So 1, 2, 3, 4, 5 lines of code to all of this. So I don't know about you, I think this to me is simpler. And it's a very good example of the power of Scala, because you can use loops, collection, function literals, and tuples. And loops, of course, are present in Java, but the collection API in Scala is a bit more powerful. You have also function literals that are not present in Java, and you have tuples, which is a data type. That's a bit different. There's another thing that's very interesting, and it's the implicits. So you can, for instance, seamlessly convert from different types. So for instance, you can convert from Java util concurrent to Google Guava library. And you only need to import an implicit conversion to do it. So it's done all automatically. Another thing that's very nifty is since Scala doesn't have any primitive types, like an integer or a double, everything is an object. So for instance, if I were to declare a myData object, and I wanted to invoke 2 plus myData, in Java you can't do that because 2 is a primitive type. It's an integer primitive type. But in Scala you can do that with implicits. So you can extend the already primitive objects to be able to do this, which is very interesting. The other thing that's going to be very interesting is traits and mixin. So basically, in Java you cannot you can implement multiple interfaces, but you cannot extend multiple classes. So in this case, we have a mixing class with 2 traits, and you can see that the mixing class extends mix with DJ, and you can see that it uses values in those 2 traits. Another thing that's interesting is pattern matching over class hierarchies. So it's very useful because everything in Java, not in Java, but in OpenDaylight is an XML tree. So you have the ability to match on this type of trees very easily with case class and pattern matching. You don't have any mutable states, so it's easier to reason and debug code because you don't have a function that's modifying 10 variables and then you're not really sure what's happening. You know that function has an input and it outputs something, so there's no side effects, which is very recurrent in Java. It's also very easy to unit test. As I said, functions have inputs and outputs. So if you unit test a function, you know that you give it something and it outputs something. So it's very easy to test. And another cool feature is when Scala was written, they decided to build in the XML parsing within the language. So for instance, if you have an XML example on the bottom, you can see a channel with the title, items, title, forecast, and so forth. And you can see the object here parses that XML file just with backslashes. So you can do built-in deep XML searches by just writing backslashes. And you can see I don't have any imports, so that's built in Scala. Also, I found another library that's pretty interesting while actually writing this talk. It's an automatic way of doing bindings for XML files. So you basically input an XSD definition file, and it's going to generate the bindings for that file automatically. So we can see we have an XSD, because the reason for this is that OpenDaylight is an XML living document. So basically you have data change on an XML document that changes over time. And so XML is an integral part of OpenDaylight. It's very important to it. And so that library, as I said, you have an XSD document that you can define how your XML document is syntaxed. And then you just build with a plugin, and it generates case classes. So it's all done automatically with XSD. We can see, for instance, ship2, and you can see where's the ship2? Ship2 is here, so it's pretty aligned with what's in the XSD document. Also, OpenDaylight I think needs new blood as the project evolves over time. It's always interesting to keep new blood coming into the project so that the project is maintained. And we can make that fun and interesting by introducing Scala. Scala is hot, and it makes for very elegant and concise code. It's also a good challenge for anybody who wants to learn functional programming. And the new generation of developers, as time goes, they will likely learn new languages on top of the JVM. So they might learn Jython, Clojure, Scala. So they might learn this. They might prefer to code this on these type of languages more than in Java. And also to retain an existing developer, because you give them a new way to express themselves in their code. Because Java is because Scala is a more expressive language, you can do more with it. So a couple of frameworks that can be leveraged. So of course we have Akka. I've tried implementing an RPC in OpenDaylight using Akka, using actors. The only issue is as I said, well, I didn't say it, but in the slide where I say we can convert from concurrent, Guava, concurrent, and Scala future. Well, that is where I discovered that. The only issue is that the libraries, Guava, Java 8, and Scala, they don't necessarily do it the same way. So for instance, in Java 8, you can interrupt a future, but you can't in Akka. I'm not sure about Guava, and I'm not familiar enough with it. You can also, another interesting thing is that you can also leverage existing Java libraries and vice versa. So Java can use Scala and Scala can use Java, because in the end it's all bytecode. Also Scala XB, which is the plugin I was referring to earlier, so we can basically create case class based on an XSD document. Two testing frameworks that we can use for testing, Specs and Scala Test. And there's a couple of other projects on this. If you're interested to to see what can be done with Scala. Okay, so I'm going to talk a little bit about Scala bindings. I have two examples for that. So for those who are unfamiliar, Scala bindings in OpenDaylight is that you start with a Yang file, and then you compile it, and then it generates a bunch of Java files and Java interface and POJOs that represents that Yang file that you've just built. So I don't know if you've looked at the spec, how it's done, but there's a couple of problems. Notably, you cannot extend multiple times, but this is something that's built in Scala with traits and mixin. Another thing that's interesting for Yang files, for Yang tools, would be multiple classes per file, and also, of course, case classes and pattern matching. So I have a small example of a module. So we have the my module here. Actually, it's just a container plus an augmentation. So I have two Yangs file defined. So here I have a my module and an augmentation, module augmentation, and we can see that my container is empty, and we can see that we have the augmentation of my module with my container with a leaf name of type string. So the current spec, which is a v1, this is the classes that are generated when you compile this code. So it's fairly, there's a couple of classes that could be scrapped because of mixing. So in this case, we have everything is regrouped in the my container implementation. So for instance, you have my container, and then my container implementation, and then for instance, you always have a builder with depending on your data. And basically, it's pretty complicated, the code that you generate, because Yang is more expressive than Java, and so you're kind of Java is not as permissive or expressive as Yang, so you have to find hacks to create to express Yang in another way. So this is a Scala equivalent for the same Yang definition. So this one, and we can see that by using traits, we get rid of my container implementation, and with mixin, everything is in my container, and like it simplifies the classes diagrams much more than the previous. So this versus this. And I have another example. So we have a grouping in a my container again. So my container uses the grouping 1, which contains a leaf, my leaf of type string. And then when we compile that, it generates a bunch of classes again, a bunch of interfaces, and with all the implements and extends and everything. And the Scala equivalent with traits would look something like this. And again, we get rid of the my container implementation, and everything is in my container instead. There's lastly, we've talked, I'm not sure we've talked much about it, but we can use higher order functions in Scala. So what is a higher order function? So a higher order function is a function that takes one or many functions, and that returns a function as its result. So that's very useful, for instance, when you have you want to combine many things together, but you don't want to necessarily return a value. You want to return a function as its return type. So in this case, you have a bunch of operations. So read the data store, read something else, read even more, and write something. And all those operations, you have a last operation with need all operation completed. And all the operation, they might take some different amount of delta time. So for instance, read might take 1 second, and then read even more might take 10 seconds, but you want everything completed. So Scala, with higher order function, you would have the ability to write something like this. And not only you have the ability to write it, but it's going to be much more concise than in Java. This is just a simple example of this, basically. So we have, so it's in this case we have await all, which is a function that takes a bunch, one or many functions, and returns a function as its result. So it's a higher order function. And so we define two functions. So in this case, we want to ask the actor something, and then we can see the actor sleeps for 1 second, and then replies hi to the sender. And operation 2 is the same thing. So those two operations are both futures. So we don't know if we're going to have it in 10 seconds or 1 second. We have no idea. So in this case, we want to await all of these at the same time. So we would pass the two function, which is these, and then with the result, just print the result combined together. So that would be an example of how we could simplify this type of operation. So if you're interested, I've written a small example with it doesn't have any binding, so it's still using Java bindings to CRUD or to access the data store. And basically it's on GitHub, Sniggle, Scala Cup, so if you're interested. There's still a fairly good amount of Java, except in the implementation package or the implementation bundle. And this has been made possible because of the the switch from config pusher to blueprint. As if you're aware of what's happened in OpenDaylight, we switch from config pusher config files to blueprint. So with this, it's possible to inject Scala class directly in OpenDaylight. So it's fairly simple to do that with it. And also a foreword about the usable feature. I think I already talked about it, but just converting from different futures is a bit problematic. So we might want to support Scala future also in OpenDaylight. That would simplify things. And yeah, that's basically a presentation. Any questions? I like to hear feedback if possible. If anybody has something, I hope it was interesting.
Yes. So how much does the story change if you compare Scala to Java 8?
Yeah.
Like all the stuff about first order functions, higher order functions, the streaming collection operations.
Yeah, okay, that's a good question. So there's still, it's good. The Java 8 API is good for collections and like the stream and the collect. It's all very powerful, but it's also very verbose. So that, like, you have to write a lot of things to be able to do the same one-liner you would be in Scala. It works fine, but you still don't have access to tuples. Higher order function, I don't think that's in Java 8. You don't have, for instance, mixin. It's not in Java 8. I mean, there's a bunch of, like, it's good. The collection and what they did in Java 8 is good, but it's not enough, in my opinion. But one of the main things which I think Java Scala might be easier to think about is mutability. Because in Java, you have a lot of variables that you declare on your class, on top of your class. And so you might call a function that's going to modify 10 variables. And your function might have 20 lines of code. But it's very hard to keep up with everything that's been done in that, because all your variables that are on top of the class are being modified at the same time. I'm not sure what's happening with that, because it's just difficult to reason about. Whereas Scala, you take an input, an output, and that's it. And everything is immutable. To me, I find it easier to reason about. But it's just, what I'm trying to say here is that it's at its core. I mean, we would have to modify Java at its core too much to be able to be the same as Scala. Is what I'm trying to get into.
Yeah, but the immutable stuff you can do in Java as well. But I think that the really interesting argument there is the mapping between Yang models and mixins.
Yes, exactly. Yeah, I totally agree with that. And also, I think they're currently doing the bindings version 2, and I'm not sure where it's at, but I saw a document. They're using a lot of hacks to get around the fact that you can't express the expressiveness of Yang versus Java, and it gets complicated a little bit because you create packages with namespace, and then you might have something else that has another packages, but it's in the same Yang, and it gets complicated. Yeah. Any other questions? Okay. Well, I hope it was interesting. Thank you for listening, and thank you for listening with an open mind. Thanks.